All right, guys, today we're going to talk about page number 30 in your notes. It says molarity at the top. The concept of molarity really doesn't have anything to do with stoichiometry because you don't need a balanced chemical equation to do these problems, but we're going to use the concept of molarity to help us. First, we're going to learn what it is today. It should be pretty simple, and then we're going to learn how to do stoichiometry involving molarity on our next notes on page 31. Okay, so you're going to need a calculator, something to write with, and a highlighter if you have one. Okay, so concentration. It says the concentration of solutions can be defined in many ways. So hold on, what's concentration? Well, if you think about it, I'm going to do a little visual here. Let's see if it works. If you think about concentration, if I have a solution, right, meaning something like dissolved in water here. I've got 2 different cups of water, same amount of water in each one. Which one, and I'm going to put some food coloring into one. I'm going to put 1 drop into this one, and I'm going to put 3 drops into this one. Maybe I'll do 5 drops. 5 drops into this one, just really give the visual. And then I'm going to swirl them around. Swirl, swirl, swirl. Swirl, swirl, swirl. It's not perfect. Okay, it's just food coloring and water. But this will give you a visual. Which one is more concentrated? This one's more concentrated, right? Because this one has more of your solute. This is your solute, the food coloring. It has more solute per, I guess, per liter of solvent. And solvent is your water, okay? So there's more food coloring in this one for the same amount of water than there's in this one. So this one's more concentrated, this one's more diluted. Okay, it's just like when you're making chocolate milk, you want to add enough chocolate to get it nice and chocolatey. You want a good concentrated solution, and then this would be kind of like a watered down version. This would be a dilute version, okay? Now there's a way we can mathematically measure this, okay? And the units that we use often in chemistry to measure how concentrated a solution is called molarity. Okay, so that's what molarity is. The concentration of solutions is defined in many ways, but a common way to express concentration is molarity. Molarity. So let me zoom in on that. So that's what molarity is. It's just a way to measure or to define or to express concentration. And its units are moles per liter, and it's expressed right here as a capital M for molarity, okay? And it's read as molar. So if I had like 0.5 M, that would be 0.5 molar solution, and that would mean that for every 0.5 moles of whatever that is, there'd be 0.5 moles of, if this was like table salt, NaCl, that would mean there'd be 0.5 moles of NaCl for every liter of water. That's what that would mean, okay? So again, molarity is moles of solute per liters of solvent. So molarity is capital M, it's moles per liter. So what is this triangle here? You guys have maybe seen this before, like when you guys learned about density in 6th or 7th grade. If you ever have a 3-variable equation that looks like this, you can put it into one of these triangles. So if you have a highlighter, let's just make it real obvious like this. So whatever is on top goes on top. So mole goes on top. Remember, MOL stands for mole. Capital M stands for molarity. Okay. So now, whatever you are looking for, we're going to write this down so that we know. Cover. Uh-oh, my marker's dying. Gotta use the other side. Cover what you are looking for. Cover what you are looking for. Cover what you are looking for with your finger, okay? So if I want to solve for molarity, I cover molarity, and I know it's moles divided by liters, okay? If I want to solve for liters, I cover that, and I know that it's moles divided by molarity. If I want to solve for moles, I cover that, and I know it's going to be molarity times liters, because they're side by side. That would be times, okay? All right, let's do some practice problems. The first one says calculate the molarity of an 11.22 liter solution containing 5.34 moles of cesium carbonate. Okay, so what am I given in this problem? Well, I'm given 11.22 liters and 5.34 moles. And it wants us to find the molarity. So I know if I'm looking for molarity, cover molarity with my finger, it's moles divided by liters. So I'm first going to write down that. Okay, so I'm going to do my moles, 5.34. So I'm going to go 5.34 moles. Remember, MOL stands for mole. And L is liters, and this is in liters, so I can go divided by my 11.22 liters. That's it. So I'm just going to plug that in. 5.34, oops, that's not right. 5.34 divided by 11.22, and that's what I get. So I'm going to write my unrounded answer first. So I got 0.475935 dot dot dot. And then how many sig figs do I need? I have 4 sig figs here. I have 3 sig figs here. So I'm going to go with the smaller one. So my answer only needs 3 sig figs. So I'm going to go 0. Because this doesn't count as a significant figure. 4, 7, and then this 9 would bump that up to a 6. And then what are my units? Moles over I was solving for molarity, capital M. So I'm going to go capital M. Okay, that's how you do it. Easy enough. You just plug in numbers in. Okay, let's see if we can make it a little bit more difficult. So this example says calculate the moles of scandium 1 nitrate in a 6 molar solution with a volume of 1,522 milliliters. Okay, so what am I given? I'm given molarity, I'm given milliliters, and I'm trying to find moles. It's asking me to find moles. So if I want to solve for moles, I need to cover moles with my finger. And that means I need to do molarity times liters. This is times. Okay, so moles equals molarity times liters. Okay, so now I'm going to do my molarity, my 6.0 molarity, times my liters. But wait, is this in liters? Nope, that's in milliliters. How do I convert milliliters to liters? Well, what you're technically doing is, if you want to see the math to understand how it works, there are 1,000 milliliters in a liter, so you can do a conversion factor. There's 1,000 milliliters in 1 liter, so you're really dividing by 1,000. So if I do, just to show you guys the process, if I do 1,522 divided by 1,000, I get 1.522. Okay, now 1.522 liters. Now, shortcut way to do it is you just remember to go from milliliters to liters, you move the decimal place to the left 3 times. You just go whoop, whoop, whoop. You do 3 times this way, and that's how you get to liters if you're coming from milliliters, okay? So I'm going to go, I need to plug in liters into my equation here, so 1.522 liters. Okay, so that's how I can make it a little trickier. You have to make sure you're in liters for this formula. Okay, so I'm going to go 6.0 times 1.522, and I get 9.132. So I'll write my unrounded here. And then how many sig figs do I need? I have 2 sig figs here. I have 4 sig figs here. I need to go with my lesser number, so I need 2 sig figs. So it's just going to be 9.1 and moles. Okay? Okay, next example. It says calculate the molarity of a 852 milliliter solution containing 8.56 grams of chromium 3 nitrate. All right, so there's like a glare there. This is grams. This is milliliters. So I'm trying to make these progressively more difficult. So if no matter what they throw at you on comps or on my test, you'll be ready for it, okay? So it's asking you to find molarity. So let's cover molarity with our finger. Remember, capital M for molarity. So moles over liters is what I'm doing here. moles over liters. But okay, here's the problem. Do you see any moles here? Nope. Okay. Do you see any liters? Nope. So we're going to have to convert both of those. Can we convert grams to moles? Yes. Yes, we can. We know how to do that because we have been spending all year doing that. But in order to convert this to, first thing you need to do is you need to write the formula for this in order to calculate the molar mass of it. So let's see, chromium 3 nitrate. So chromium would have a charge of 3, because it says right there plus 3. And then nitrate is a polyatomic ion, which we all have memorized, right? It's NO3 with a -1 charge. Crisscross those. And it's CrNO3 with a 3. Okay, so that's a 3 and that's a 3. CrNO3, 3. Sorry, that got a little smudged there. Okay, so we need to take these grams and we need to turn them into moles. So let's do that kind of right here. We're going to go 8.59 grams. So grams needs to go down here. 1 mole needs to go on top because that's what we're looking for. So we're basically dividing by the molar mass here. Molar mass of this, I will just tell you guys for the sake of time, when I calculated it, so I looked at my periodic table, I found chromium, I found nitrogen, I found oxygen, I multiplied my oxygen times 9, my nitrogen times 3, all that good stuff, added up my molar mass, and I got 238.03. Sorry. 238.03. I know that's like impossible to read. 238.03. Okay, so I'm going to divide those two numbers, and I get, let's see, so I get 8.59 divided by 238.03, and that's what I get. So I will just round that to 3 sig figs, and that would be 0.0361. 0.0361, and that would be my moles. Okay, so now we know our moles. We can plug that in here. 0.0361 moles over our liters. So remember, the shortcut is you take the decimal. If you don't see one, that means it's right here, and you move it 3 times to the left. 1, 2, 3. So it's going to be 0.852 liters. Okay, so now we have our moles, we have our liters, we can divide them. So we're going to go 0.0361 divided by 852. And this is my unrounded answer. Let me write that down. 0.042378, blah, blah, blah. How many sig figs do I need? Let's look at our original problem. This has 3 sig figs, this has 3 sig figs. So this is going to need 3 sig figs. Remember, leading zeros don't count. So it's just going to be 0.042, and then you look at your 4th significant figure over. Is it going to bump it up? Yes, it is. So it's going to be 424. And then the units we're looking for are molarity. Remember, capital M is molarity. Okay? All right, almost done. Okay, I'm trying to make these as difficult as humanly possible. This is as hard as I can make it. So if you understand what's going on, great. Really, you just need to make sure you're finding, like if you're solving for molarity, you need to get your grams into moles, get your milliliters into liters, and you're good. Last one, calculate the mass of solute in a 0.250 liters of a 6 molar solution of sodium carbonate. Okay, this is interesting. So it's asking us to find mass, which is grams. Okay. And it gives you liters, it gives you molarity. Does this say anything about grams? No, but it does give you liters and it does give you molarity. So that must mean that we're going to be solving for moles. And once we're in moles, can we convert to grams? Yes. Yes, we can. So let's make a note to ourselves. This will help us on the homework. Solve for moles first. Okay, let's solve for our moles first. Okay. So we're going to solve for moles first. So for solving for moles, a cover moles with my finger, I'm going to do molarity times liters. So let's solve for moles. So moles equals molarity times liters. Here's my molarity, here's my liters. So let's just plug those in. Molarity times our liters. When we put that in our calculator, we get 1.5. Okay, so this would be our moles, 1.5 moles. 1.5 moles of what? Because we need to know what it is in order to convert to grams, right? Because we're asked to find mass, and mass is in grams. So it's sodium carbonate. Sodium carbonate. So let's come over here. So sodium has a +1. Carbonate is a polyatomic ion, as we all know, because we have it memorized, right? Carbonate is CO3 with a -2 charge. So it's Na, when we crisscross those charges, or drop charge method, as some of you call it, you put a 2 down here, right there. Okay, swap and drop. Okay, so we've got Na2CO3 is what we're dealing with. And we need to convert that to grams, right? So we have 1 mole on the bottom. We have grams on top. Okay, so we need to find the molar mass of this. And I'll just, for the sake of time, tell you what I got. So I looked at the periodic table, I looked all these up, I added it all up, and I got 105.99. 105.99. Okay. Sorry, it's getting a little crowded because the other half of my pen stopped working, so I have to use the Sharpie. Okay, so now we're going to multiply by our molar mass to get grams. So notice it's the opposite of this problem. This problem we were given grams, we had to convert to moles. This problem we had to, from our moles, we had to convert to grams. So that's why we're multiplying instead of dividing. So we're going 1.5 times 105.99. And we get this big number here. How many sig figs do we need? 3 sig figs, because this one has 3 and this one has 3. So this one and 3 sig figs. Here, let me write my unrounded answer here. I got, in my calculator, I got 158.985. 3 sig figs. This 9 would bump this up to a 9. So it'd be 159 grams. Because it says calculate the mass in grams, that's what we did. Okay, and that's how you do it. And guys, these calculations are actually like I use these calculations on a regular basis. Maybe not so much this year because we don't do too many labs this year, right? But in a normal year, whenever I have to mix solutions, I get very concentrated solutions from the chemical company, and I have to dilute them so that I'll have enough for all of my classes, and I need to. If I need to calculate that I need like a certain molarity of a solution, I figure out how many grams I need to add to how much water, and that will tell me basically what concentration I'll get, because certain reactions will only occur with certain concentrations of solutions. So this is definitely something that I use on a regular basis, and now you kind of understand how I do it. So if you guys flip over here to the back, oh, mine's all messed up, but on the back of your paper, you're going to have, it says you tried, and you have 6 problems to do. Now I want you to keep in mind you need correct sig figs in all of these. Make sure that you round everything to correct sig figs, okay? There's 6 problems for you to do. This is the homework basically, okay? It's all of these you tries, all right? So go ahead and work on that.